students. In this video, I am going to discuss solubility concept and solubility product concept. Next, numericals. It may take 2 videos, students. Without concept explanation, directly we can move on to the numericals. You may get so many doubts. To avoid this one, I am explaining first briefly concept, then we move on to the previous year questions. Solubility product questions plays important role. Actually, they are connecting solubility product and electrochemistry. Equilibrium and electrochemistry, both they are connecting, and mains examination integer type questions they are asking more. And NEET questions also very important. In previous year pH, they are adding pH also. pH and solubility product combinations, so POH solubility product combinations, and common ion, after adding common ion, what happens solubility, whether it is decreases, why it is decreases, on what basis. So many questions we have, theory questions plus numerical part both. So first let me cover first theory part in this video. Next, immediately I am going to upload numerical, 4 different numericals. Okay, students. First, we look into the solubility definition. See, I have written to save the time some points. 100 grams of solvent I am taking. Fixed amount of solvent. 100 grams of solvent and 1 gram of solute. Okay. Now come back to the solubility. What is solubility? Amount of salt in grams dissolved in 100 grams of solvent. So how much amount dissolved? So that we can calculate amount of salt in grams dissolved in 100 grams of solvent. So that is nothing but solubility. Okay, this is basic definition. Now here soluble salt. It is more soluble. So we are seeing in labs also, and we are hearing soluble salts, more soluble salts, sparingly soluble salts, insoluble salts, right? What is more soluble salt? That means, see, more than 1 gram present in 100 grams of solution. That we call it as more soluble salt. Sparingly soluble is nothing but definitely less than 1 gram. Less than 1 gram present in 100 grams of solution. So this is nothing but more soluble salt, sparingly soluble salt. So and insoluble also there, that we are not speaking much. But here solubility product mainly we are concentrating sparingly soluble. Sparingly soluble salts also call it as partially soluble salts. Okay, previous video in chemical bonding also I have uploaded one video. So maybe you have seen that one, part 3 or part 4. I had explained lattice energy, hydration energy, and next one solubility also. So where radius of cation and radius of anion is large, then solubility is more. So I have given shortcut, go through that video. Solubility important role. Solubility concept plays important role in competitive. Now, highly soluble salts. Highly soluble salts, generally nitrate salts. Most of the salts are soluble, students. But generally in nitrate salts are more soluble. And first A group also. First A group like sodium, potassium, rubidium, cesium, like this. And francium is radioactive element, and lithium has more lattice energy. That is why it is less soluble when compared to others. And ammonium salts also, ammonium chloride. In cold water condition itself it dissolves, right? Now next one, sparingly soluble. Here our concentration is more. Sparingly soluble is nothing but less soluble. Okay, less solubility is different, insoluble is different. Sparingly soluble is nothing but partially soluble, less soluble. AgCl, generally silver salts, silver chloride, silver bromide, silver chloride, white precipitate, silver bromide, so pale yellow, barium sulfate also, sulfates also partially soluble. Okay, clear, students? And within the group also, suppose barium sulfate, beryllium sulfate, which is more soluble. So based on these questions, I have uploaded in chemical bonding Bonding part 3 video. You can watch it if you want solubility concept more. Unsaturated. Next questions. Now we'll start the questions. This is a briefly I had explained the definitions and all students. Now come back to the actual points. Generally, we are hearing three important points. Those are unsaturated condition, saturated condition, supersaturated condition. To understand this one, I am giving one example. So suppose you are feeling hungry, right? You are having food. So having food, early stage, starting stage, that means you are accepting more, you are taking more, right? So you are having more means that is unsaturated condition. Starting stage we call it as unsaturated condition. Saturated is nothing but it's looking like feel like heavy after ate something you feel heavy. So that is nothing but saturated condition. No more solute can be dissolved in the given amount of solvent. It's not possible to eat. Content is there. So, but what is the food is there, but it is unable to eat, right? That is saturated condition. Even people morning to evening listening classes also feel like saturated condition. That means it's not possible to accept into brain, right? Here, one more condition, supersaturated. Supersaturated means very few salts we are talking, students. Supersaturated condition, how it is dissolved, maybe you will get doubt. But we are adding some, we are changing some conditions, or else we are adding the suitable electrolytes, suitable salts, common ions we are adding, then solubility, it increases. So that concept also we will discuss based on one numerical. But here, listen, first see the points. Solute ready to dissolve. That is unsaturated condition is nothing but starting condition, students. When you are having food, more hungry, starting stage. So starting stage, less than required solute dissolved. So you are still having hungry, you are having, right? So less than required solute dissolved. Okay, your understood? Here next one, saturated. No more solute can dissolve. So saturated and saturated feel also most of the students also feel like the same thing after 5:30 they don't want to listen classes, right? So same here also required amount of solute is dissolved. How much we expected? Suppose timings is up to 5 o'clock. Yes, up to 5 o'clock you listen. So that's completed. So after that you are going to saturated condition, right? Now next one, supersaturated. Supersaturated means I said one point. We are changing some conditions. Suppose AgCl is there. AgCl is partially soluble. AgCl is partially soluble. To increase its solubility or to increase this solubility, we are adding common ion, NaCl. NaCl is completely dissolved. It's soluble more. So we are changing some conditions. Finally, it's soluble. Solubility increases. So very few cases, students, that is generally hypo, sodium thiosulfate, hypo. Okay, this is about saturated, unsaturated, supersaturated. Those 2 points, these 3 points also plays important role for concept. Next one, solubility product. Yes, this is our next main important topic, solubility product. Okay, students, now I am talking here sparingly soluble. One hypothetical salt I have taken. One hypothetical salt I have taken, that is AB type. AB type, you can take it. A is nothing but one atom, like NaCl type, you can take it. KCl type, you can take it. First A group element, cesium chloride, ammonium chloride, like this we can take it. Now, first I have taken AB. Okay, I have put in water, just adding into solvent. Once I put in solvent, this is in solid state now. So once we put in solvent, then what happens? It dissolves. Some salt dissolves, right? It is sparingly soluble. So sparingly soluble means definitely it can dissolve some extent. Once it dissolves, it can't sit like this. Immediately it dissociates into ions, A plus and B minus. Whatever soluble salt is there, it is coming like a ionic form, which is undissolved, again equilibrium condition, again dissolving, again coming to the condition. Now, I am writing Kc expression, K. We know K expression. What is K expression? Concentration of products by concentration of reactants. Products. You can take these two combinations, starting undissolved to dissolved, completely ionic form you can take it, or else these two also you can take it and write. So I have taken these two students. Now concentration of products. This is up these two, AB and A plus B minus we are seeing. Here A plus and B minus, concentration of products by concentration of reactants. This is undissolved. Undissolved. I have taken these two combinations, or else you can take these two combinations also, no problem. So undissolved salt. Undissolved salt you can bring one side, K into AB equal to A plus B minus. Right, students? Now, instead of writing two constants, this is, you take it as a AB is constant only here. Why? Because that is undissolved salt. Undissolved salt is no dissociation, right? You take it as a constant, unity 1. So instead of writing these two, I am writing KSP, that is solubility product. KSP of AB type equal to A plus B minus, like this. You will get the answer. Clear? And one more shortcut I am giving here. One more shortcut I am giving. This is concept-wise explanation. But in towards competitive examination, within less time, how to solve the questions. See students, some different solves I have taken. Different KSP, different sparingly soluble calculation for KSP I am taking here. AB type. NaCl, KCl, cesium chloride, NH4Cl like that. AB2 type. Here students important point. AB2 type or A2B type. Both are same final answer. Both are same final answer. I can show an example. See, magnesium chloride, lead chloride. This is AB2 type. This is A2B type. Final answer is same. Here AB3 type. AB3 type is aluminum chloride, like third A group element salts we can take. Generally aluminum chloride we are taking. Iron chloride like that. Okay. Now students we can calculate here. So I said one more shortcut. You always no need to take AB undissociated, then dissolved, then afterwards again what is this ionic form, then Kc. No need to take that. So we are taking one shortcut here. So we know every video some shortcuts we are taking. So here AB type students. AB type. See. Here KSP equal to x to the power x, y to the power y, s to the power x plus y. Okay, now let me take AB type. AB type, how it can dissociate? Tell me students. A plus B minus. Once dissolved in the water, once dissolved in the solvent, definitely it can dissociate into A plus B minus. Yes. What is here? What is how many moles here? Here only 1. So there is no number means 1. Then x equal to 1. Here there is no number means 1. X1, Y1. You can substitute now. KSP equal to x to the power x, y to the power y, s to the power x plus y. Right? 1 to the power 1, 1 to the power 1, s into s to the power 1 plus 1. Then what you will get here students? S square. Right? KSP equal to S square. Then S equal to, tell me, what is this? What you will get S equal to? Yes. S equal to root over KSP. That's it. So numericals, you can expect numericals here. Either they will give S value or else KSP value. If you know the final expression directly, you can take it. But always you can remember all the expressions, it's difficult. You can use this shortcut and simplify this one, then you can substitute. Suppose KSP, they had given some value. So 4 into 10 to the power of minus 6 something. So then S equal to, this is KSP they had given. Substitute here. So root over 4 into minus 6. Then 2 into 10 to the 3. Solubility product units. Solubility product units. KSP units. Moles per liter. Moles per liter. Here students, like this we are solving. The same question you can go in different way. See. Here also, some of the students, they were calculating like this. So like this, here they are adding, this is yes, this is yes. Okay, so concentration of A is S in terms of S, concentration of B also S, then KSP equal to S equal to root over KSP. This expression also you will get the same one, and what we are using the shortcut also will get the same thing, but better to remember shortcut. Clear students? Now go through the point and note it down, practice. Now I am giving one example to you. Okay, so we'll work out here students some pieces there. Yes, I am giving one question here. Look into this. What is this? AB2 type. AB2 type. And A2B type. Both types you will get the same thing. Here just you can write what is this value, x equal to 1, y equal to 2. Right. Here this x equal to 2, y equal to 1. Just to ulta. So here KSP equal to x to the power x, y to the power y, s to the power x plus y. Right. So 1 to the power 1, 2 to the power 2, s to the power 1 plus 2. Finally, you will get 4s cube. Then s equal to, tell me, s cube equal to ksp by, so this is finally ksp. ksp equal to 4s cube. So s cube equal to ksp by 4, or else you can write cube root. So s equal to cube root of ksp by 4. If you will take this one also, same answer you will get it. Clear? So now next one, we can do next question. Okay, so this is what is the question I had given. What is the question? AB3 type. AB3 type. AB3 type is nothing but AlCl3. AlCl3, here what you will get expression? Tell me. Can you tell? X equal to 1, y equal to 3. That's all students. You can substitute. If you find out yes, x and y, then remaining is very simple. To the power 1, 3 to the power 3, 4. What is this? S to the power 1 plus 3, right? Then KSP equal to 27, S to the power 4. Then S4 equal to KSP by 27. Then S equal to, tell me, 4th root of KSP by 27. This is your final expression. That's it, students. Clear? So like this we can do numericals. They will give one value. Other value we have to calculate. Clear? Now next video I am going to do the numericals. But first you have to practice formulae. Now next one. This is one of the most important model, for most of the students are confusing here only. If soluble salt with common ion dissolved in the sparingly soluble salt. So in above case, I have given one point. Generally, silver salts are partially soluble, sparingly soluble. Silver salt I have taken. First of all, he is partially soluble. Now, to increase the solubility, then what we are adding? NaCl. So increase the solubility or decrease the solubility, that leave it. So for this partially soluble salt, I am adding one common ion salt. Then what happened? What happened? Solubility we can see. Whether it is decreases or increases, we can see. Okay. So see here, AgCl partially soluble and NaCl is more soluble. So what happened? NaCl is partially soluble. No, partially soluble salt we are writing like this equilibrium way. Ag plus Cl minus. Ag plus Cl minus. So better you will take your concentrations. To understand this one, I will derive one expression. X, this is S, this is S. NaCl. NaCl is strong electrolyte. NaCl is completely dissociation. Dissociation is more. Ionization is more. Na plus Cl minus. Okay, students, like this. See here, which is common ion? Cl minus is common ion. In vessel, we are getting Cl minus ions means the Cl minus is coming from both. From AgCl we are getting and NaCl we are getting. But NaCl we will get more. AgCl will get less. Clear? Why? Because it is sparingly soluble salt. For this type of numericals, they are given how to solve. Suppose take it as some concentration value 0.1 molar. You can take it. This is also 0.1 molar. This is also 0.1 molar. Units are moles per liter, no molarity. Now you can write expression KSP equal to Na plus Cl minus, because which is more soluble Na plus Cl minus, that I am taking. So then KSP equal to Na plus Ag plus ions only 1 1. You can write only Na plus ion is nothing but yes. Okay, and Cl minus ion concentration is nothing but Cl minus ion concentration. So here we have to take both. We have to take both. If you are not taking both, no, you will get wrong answer. 0.1 plus S. 0.1 plus S. Clear, students? I am writing remaining one. Now KSP equal to S into 0.1 plus S. But here, this is, students, very important point. Very important point. Listen carefully. Here, this is partially soluble. AgCl is partially soluble. Here, Cl minus ion concentration is less. But you come back to here, NaCl more dissolved. It can more dissolved in the solvent. It gives more ions, Na plus ions, Cl minus ions. Is the dominating guy now. Right. So Cl minus ions we are getting means definitely it will be both the salts. It is giving both the salts. But who is giving more? He is giving more. If Cl minus ions concentration is increasing in the vessel, according to Le-Chartier's principle, what happens? The reaction moves towards backward direction. Right? So see, Cl minus ion concentration is increasing more, then reversible reaction. Reversible reaction is going back. AgCl is going back. So first of all, he is sparingly soluble, but if now concentration of Cl minus increasing, then it is going back. So according to Le-Chartier's principle, concentration of products is increasing, then it will go to the backward reaction. Here solubility is decreasing. AgCl solubility is decreasing. So that's the reason this concentration we are neglecting. So 0.1, this value is more, this concentration is more. That is why we are neglecting this one. Okay, I will do based on this one numerical, you will come to know. Just theory I am explaining here. KSP equal to, now S into 0.1. That's it, students. Now S equal to, how to write? KSP by 0.1. Clear? Like that. If you are not considering this value, students, you will get wrong answers. So when we have to consider, when we are not considering, so one numerical I will explain, you will understand more. Next, ionic product. Ionic product also directly theory questions we are getting. So one again we are taking hypothetical salt AB. AB gives rise to A plus B minus. Here we are writing ionic product. IP is nothing but ionic product. Ionic product is nothing but starting at any concentration. Unsaturated solution. Unsaturated solution at any concentration.